silent, completely cold, and completely alone. Its surface is painted in shades of rust and blood red. Winds tear across it at 60 miles per hour. Its sky turns a pale, haunting blue at dusk, not because it is beautiful on purpose, but because physics works the same way everywhere in this universe, even where nothing is allowed to notice. That planet is Mars, and the reason you should care about it has nothing to do with science fiction, rocket launches, or the ambitions of billionaires. You should care about Mars because it holds a mirror up to everything we are, everything we were, and everything we might become. It tells a story, a terrifying, awe-inspiring, deeply personal story about life itself and how rare it actually is. You're watching this right now because some part of you already senses that the universe is bigger than the life you're living, and that feeling you get when you look up at a night sky and feel small, that is not weakness. That is intelligence recognizing the truth. So let's go there, all the way out, no turning back. Before we even get to Mars, before we talk about black holes and alien life and the fate of everything, we need to start at the beginning. Not the beginning of Earth, not the beginning of humanity, the actual beginning. 13.8 billion years ago, there was nothing. And before you move past that sentence like it's just a number, stop, sit with it. There was no space, there was no time, there was no darkness, because darkness requires space to exist inside of. There was not even silence, because silence is the absence of sound, and sound requires air, and air requires a universe, and there was no universe. There was nothing. And then, in a moment so violent and so incomprehensibly energetic that no human language was built to describe it, everything exploded into existence. All of the matter that would eventually become you, the chair you're sitting in, the sun, Mars, the Milky Way, and 2 trillion other galaxies, all of it emerged from a single point smaller than the period at the end of this sentence. That event is what we call the Big Bang, and it is the most important thing that has ever happened, because without it, nothing else on this list exists.
What makes the Big Bang so haunting is not that it happened, it's that we still don't fully understand why. The laws of physics, as we know them, break down completely in those first fractions of a second. Einstein's equations, which can describe the bending of spacetime around a black hole or predict the orbit of Mercury to extraordinary precision, simply stop working when you rewind the universe to its very first moments. It's like asking a map to describe a place the map was never designed to include. Scientists call this the Planck epoch, the first 10 to the power of negative 43 seconds after the Big Bang. And within that window, our best tools become useless. We are essentially standing at the edge of human knowledge, peering into a fog, and being forced to admit that the most fundamental question of all, why does anything exist, remains unanswered. That kind of uncertainty should make you feel something. It is the universe reminding you that for all of our technology, our satellites, our particle accelerators, and supercomputers, we are still, in many ways, children standing at the shore of an ocean we cannot see the end of. In the minutes after the Big Bang, the universe cooled just enough for the first atoms to form, mostly hydrogen, some helium, trace amounts of lithium. That's it. That's all there was, a vast, expanding cloud of the 3 simplest elements in existence, with no stars, no planets, no light, just gas slowly drifting through a universe that was still stretching itself outward at extraordinary speed. For hundreds of millions of years, nothing happened that would look remotely interesting to a human observer. But gravity was working quietly in the background, pulling those clouds together, compressing them, heating them, until finally the first stars ignited. And when they did, something extraordinary happened. Those stars were enormous, hundreds of times the mass of our own sun, and they burned hot and fast and died young. When they exploded as supernovae, they scattered their guts across the cosmos, and inside those stellar explosions, heavier elements were forged: carbon, oxygen, iron, gold, and every other element on the periodic table that makes complex chemistry possible.
which means every atom in your body was once inside a dying star. You are, in the most literal sense possible, made of stardust. That is not a metaphor. That is chemistry.
Those stellar explosions seeded the galaxy with the raw ingredients for planets. Over billions of years, gravity gathered those materials into new solar systems, including ours. About 4.5 billion years ago, a cloud of gas and dust began collapsing in on itself in a quiet corner of the Milky Way. The center became our sun. The leftover material flattened into a spinning disk, and within that disk, particles began colliding and sticking together. Small rocks became bigger rocks. Bigger rocks became planetesimals. Planetesimals crashed into each other over millions of years until the rocky inner planets, Mercury, Venus, Earth, and Mars, were formed. Earth happened to form in what we call the habitable zone, just the right distance from the sun where liquid water can exist on a planet's surface. Mars formed just slightly farther out, close enough to have once been warm, once had liquid water, once perhaps harbored the conditions necessary for life. That word, once, is doing a lot of heavy lifting in this story, and we're going to spend some real time with it. Mars today is a wasteland. Its atmosphere is less than 1% as thick as Earth's, composed mostly of carbon dioxide, so thin that it offers almost no protection from solar radiation or the temperature swings that go from 70 degrees Fahrenheit at the equator on a summer afternoon to negative 195 degrees at the poles in winter. There is no liquid water on its surface now, at least none we've confirmed flowing freely. Its magnetic field, which once shielded it like Earth's shields us, collapsed billions of years ago when its core cooled and solidified. Without that magnetic shield, the solar wind, a constant stream of charged particles blasting out from the sun, slowly stripped away the Martian atmosphere over billions of years, turning a potentially livable world into an irradiated frozen desert. But here's what keeps scientists awake at night. Mars wasn't always like this. 3 to 4 billion years ago, Mars had a thicker atmosphere, a warmer climate, and a liquid water flowing across its surface. We know this because the rivers left their marks. The shorelines are still there, the riverbeds are still there. The minerals that only form in the presence of liquid water, they're still there. Something lived, or at least could have lived, on Mars, and whatever it was, it may have left traces behind. NASA's rovers have been crawling across Mars for decades now, and what they've found is not proof of life, let's be clear about that, but they have found the chemistry of life. They've found organic molecules, the carbon-based building blocks that life as we know it uses. They've found methane periodically rising from the Martian soil, which on Earth is almost always produced by biological processes, though geological ones can also create it. They've found ancient lake beds where water once pooled for potentially millions of years, long enough, by Earth standards, for microbial life to emerge and evolve. Perseverance, the most sophisticated rover ever sent to another world, is currently collecting rock samples that scientists believe could contain fossilized evidence of ancient microbial life. Those samples are planned to be returned to Earth in the early 2030s. When they arrive, when scientists open those containers and begin analyzing material from another planet, it will be one of the most significant moments in the history of human civilization, because if life existed on Mars, even just simple single-celled organisms, even just for a moment on the cosmic timescale, that changes everything. It means life isn't a miracle, it means life is a rule. Here is why that matters so profoundly. If life arose independently on both Earth and Mars, two neighboring planets in the same solar system, then the probability of life existing elsewhere in the universe doesn't just go up, it explodes. Our galaxy alone contains somewhere between 200 and 400 billion stars. Most of those stars have planets. A significant fraction of those planets are in habitable zones with the right conditions for liquid water.
If life can start in two places within one tiny solar system, then the universe is almost certainly teeming with it. The famous Fermi Paradox asks the obvious follow-up question. If life is so common, where is everybody? Why haven't we heard from another civilization? Why hasn't anyone visited? Why is the universe so eerily, deeply, disturbingly silent? There are many proposed answers to this question, and none of them are particularly comforting. Maybe civilizations destroy themselves before they develop interstellar travel. Maybe the distances are simply too vast to ever cross in a meaningful time frame. Maybe they're out there and we're just not listening with the right instruments. Or maybe, and this is the darkest answer, something happens to intelligent life at a certain stage of development that prevents it from surviving long enough to make contact. Scientists call this the Great Filter, and the question of whether that filter lies behind us or ahead of us is one of the most important open questions in the entire field of existential science.
While we wrestle with that question here on Earth, the universe has been doing something spectacular on a scale we can barely comprehend. There are structures in space so massive, so violent, and so strange that they make everything we've talked about so far feel almost quaint by comparison. Black holes are real. They are not science fiction. They are regions of spacetime where gravity has become so overwhelmingly powerful that nothing, not matter, not light, not information of any kind, can escape once it crosses the boundary we call the event horizon. The smallest black holes are formed when massive stars collapse at the end of their lives, compressing their cores into objects smaller than a city but containing more mass than the sun. The largest ones, the supermassive black holes that sit at the center of virtually every large galaxy, are almost beyond description. The black hole at the center of our own Milky Way, called Sagittarius A star, contains the mass of 4 million suns. The one at the center of galaxy M87, which humanity photographed for the very first time in 2019, contains the mass of 6.5 billion suns. It is so large that our entire solar system would fit comfortably inside its event horizon with room to spare. What happens at the center of a black hole is a question science cannot currently answer with certainty. The mathematics suggest that matter is compressed into a singularity, a point of infinite density where the known laws of physics break down, just as they did at the moment of the Big Bang. Some physicists believe that black holes may be connected to other regions of the universe, or even other universes entirely, through structures called wormholes. Others believe that black holes may be the universe's way of recycling information, compressing it, and eventually re-emitting it in scrambled form through a process called Hawking radiation. Stephen Hawking predicted that black holes are not completely black, that they slowly lose mass over astronomical timescales by radiating energy at their edges. For a stellar mass black hole, this process would take longer than the current age of the universe many times over, but the idea itself is extraordinary. Even the most consuming, destructive objects in the universe eventually give something back. There is a poetry in that, if you're willing to look for it. Now, here is where the universe gets genuinely strange. Everything we have talked about so far, every star, every planet, every black hole, every galaxy, every atom in your body, and every photon of light that has ever traveled across the cosmos, all of that accounts for only about 5% of the total content of the universe. 5%. The rest is made up of two things we cannot see, cannot touch, and do not fully understand. About 27% of the universe is what scientists call dark matter, a substance that does not emit, absorb, or reflect light in any way, making it completely invisible to our instruments. We know it exists because of the gravitational effects it has on the things we can see. Galaxies rotate in ways that only make sense if there is far more mass present than we can detect. Galaxy clusters bend light in ways that require far more gravity than the visible matter can produce.
Dark matter is the scaffolding of the universe, the invisible framework around which all visible matter is organized. Without it, galaxies would fly apart, structures would never have formed, the universe would look nothing like what we observe, and yet we have no idea what it actually is. The remaining 68% is even more mysterious. Dark energy is not a substance in the traditional sense, it is a property of space itself, a kind of intrinsic energy embedded in the fabric of the vacuum. And what it does is drive the expansion of the universe, not just maintain it, but accelerate it. The universe is not just expanding, it is expanding faster and faster with every passing moment. Distant galaxies are moving away from us, and the farther away they are, the faster they recede. At a certain distance, they are moving away from us faster than the speed of light, not because anything is traveling faster than light, but because space itself is stretching between us and them. Eventually, on timescales of billions of years, those galaxies will disappear from our observable universe entirely, carried beyond the cosmic horizon by the relentless push of dark energy. The universe we can see today is not the universe our descendants, if we survive long enough to have them, will be able to see. They may look out at the night sky and find it far emptier and lonelier than we find ours. That thought is worth sitting with for a moment. Einstein showed us that space and time are not two separate things. They are woven together into a single fabric called spacetime, and that fabric can be bent, stretched, and warped by mass and energy. This is not just abstract mathematics. It has real, physical consequences that have been measured and confirmed to extraordinary precision. One of those consequences is time dilation. The closer you are to a massive object, the slower time flows for you relative to someone farther away. Astronauts on the International Space Station, orbiting at high speed, age slightly faster due to velocity and slightly slower due to Earth's gravity, and the net result is that they return to Earth a tiny fraction of a second younger than they would have been if they stayed on the ground. But near a black hole, this effect becomes extreme. A person hovering near the event horizon of a supermassive black hole would experience time passing normally for themselves, but for every hour they spent there, thousands of years might pass for someone watching from a safe distance. This is the premise of the movie Interstellar, and while the film dramatized many things, the physics of gravitational time dilation is real. Time is not a constant. Time is a variable, and that fundamentally changes how we should think about the universe. When you look at a star in the night sky, you are not seeing it as it is now. You are seeing it as it was, sometimes thousands, sometimes millions of years ago, because the light from that star took all that time to reach your eyes. The Andromeda Galaxy, which you can see with the naked eye on a clear night as a faint smudge above the horizon, appears to you as it was 2.5 million years ago when early humans were first beginning to shape stone tools in Africa. The most distant objects we can observe with our most powerful telescopes are so far away that the light reaching us left them when the universe was only a few 100 million years old, long before our sun even existed. Looking into space is literally looking back in time. The universe we observe is not a snapshot of the present, it is a layered record of the past, like an archaeological site measured not in inches of soil, but in billions of light years of distance. Every telescope is a time machine. Every galaxy in a deep field photograph is a ghost of a world that may look completely different today, if it still exists at all. Given all of this, the scale, the age, the violence, the strange physics, the invisible forces, the deep silence, where does that leave us? Where does humanity fit into a universe this vast? The honest answer is that we are, by any objective measurement, insignificant. Earth is a pale blue dot, as Carl Sagan so memorably described it, orbiting an average star in the outer suburbs of a galaxy containing 400 billion other stars, in a universe containing 2 trillion other galaxies, all embedded in a fabric of space-time that stretches across 93 billion light-years of observable space, with potentially infinitely more beyond what we can ever see. On that scale, we are less than a rounding error. We are less than a single grain of sand on all the beaches of Earth combined. And yet, and this is the thing that should make you feel not small, but extraordinary, we are, as far as we know, the only part of this universe that has ever looked at itself and asked why. Every equation, every telescope, every rover crawling across the Martian surface, every human eye turned upward toward the stars, that is the universe becoming conscious of itself. You are not separate from the cosmos. You are the cosmos, briefly organized into a form capable of wonder.
Mars represents the next chapter in that story of wonder becoming action. The question of whether humanity will go there is largely settled. The question is when, and who will survive long enough to turn that dream into a colony. SpaceX's Starship, NASA's Artemis program returning humans to the moon as a proving ground, international missions from China and Europe, the trajectory is clear. Within this century, barring catastrophe, human beings will walk on the surface of Mars. They will breathe recycled air inside pressurized habitats. They will look up at a sky the color of butterscotch and watch the two small moons, Phobos and Deimos, trace their rapid arcs overhead. They will drill into the Martian rock looking for signs of ancient life, and they will begin, slowly and painstakingly, the process of learning to live on another world. That is not a small thing. Every civilization that has ever endured has expanded beyond its original boundaries. The Polynesian people crossed the vast Pacific Ocean in wooden canoes, navigating by stars. European explorers mapped continents the rest of the world had no idea existed. And now, for the first time in history, we have the technology, not the science fiction dream, but the actual engineering capability to extend human civilization beyond our home planet permanently. Mars is not just a destination, it is our backup drive. Because we do need a backup. Earth is resilient, but it is not immortal. Mass extinctions have happened before, 5 major ones that we know of, and at least one of them wiped out more than 90% of all species on the planet. The asteroid that killed the non-avian dinosaurs 66 million years ago hit with the energy of 1 billion nuclear bombs. Another impact of that scale will happen again, not necessarily in our lifetimes, not necessarily in the next 10,000 years, but on geological timescales, it is a certainty. Beyond impacts, our own sun will eventually exhaust its hydrogen fuel and expand into a red giant, engulfing Mercury, Venus, and almost certainly Earth in approximately 5 billion years. Before that, in about 1 billion years, the sun will be bright enough that liquid water on Earth's surface will begin to evaporate permanently, ending the conditions that make complex life possible. 5 billion years is an almost meaningless number on a human scale, but the point is that Earth is a temporary arrangement. If consciousness, if everything we've built and learned and felt and imagined is to survive long enough to matter on a cosmic scale, it cannot afford to remain confined to a single, fragile, isolated rock. The implications of becoming a multi-planetary species go far beyond survival insurance. Humanity on Mars means the acceleration of science in ways we can barely predict. The study of a second living world, even if its life is only fossilized microbes from 3 billion years ago, would transform biology, chemistry, and our understanding of the origin of life in ways that would take generations to fully absorb. The engineering required to keep humans alive on Mars will drive innovations that transform medicine, energy production, agriculture, and material science back on Earth. History shows us consistently that the most demanding challenges produce the most transformative technologies. The Apollo program gave us satellite communications, memory foam, water filtration systems, and the integrated circuits that eventually became the microchips inside every device you own.
A sustained human presence on Mars would produce a technological revolution that would make Apollo look modest by comparison. The future we are trying to build for ourselves on Earth is already being engineered piece by piece by the challenge of surviving somewhere far worse.
And beyond Mars, what then? The rest of the solar system opens up. The asteroid belt contains more mineral wealth than humanity has extracted from Earth and all of recorded history. Jupiter's moon Europa almost certainly has a liquid water ocean beneath its icy shell, kept warm by the tidal flexing of Jupiter's enormous gravity, and in that ocean, life may be swimming right now. Saturn's moon Enceladus erupts geysers of water vapor and organic molecules from cracks in its southern ice cap. Titan, Saturn's largest moon, has rivers and lakes and weather systems, not of water but of liquid methane, and an atmosphere thicker than Earth's. Beyond the solar system lie thousands of confirmed exoplanets, some of them rocky, some of them in habitable zones, some of them remarkably similar in size and temperature to Earth. The James Webb Space Telescope, launched in 2021 and now operating at its full extraordinary capacity, is already analyzing the atmospheres of distant planets, looking for the chemical signatures of biological processes. It may detect them within our lifetimes. It may already have detected something worth looking at more carefully. We are living right now at the most pivotal moment in the history of our species. We are the first generation of humans with both the knowledge and the tools to extend life beyond Earth, to search for life on other worlds with real instruments rather than imagination, to peer back to the first moments of creation, to map the invisible dark matter scaffolding of the cosmos, and to begin asking questions about the nature of reality itself at a level of depth and precision that no previous generation could even have framed properly. And yet, at the same time, we are a species still fighting over borders on a planet we are actively destabilizing, still prone to the tribal thinking that served us well on the African savanna 3 million years ago, but threatens us now on a globally connected, ecologically stressed, technologically armed planet. The universe does not guarantee our survival. It does not care. The physics that created us is the same physics that will one day erase every trace of our civilization, if we allow it to. The only thing standing between the story of humanity and the silence of another dead planet is the choices we make together, in this century, on this world, while we still have the chance. Mars waits. Patient and red and ancient, it has watched the solar system evolve for 4.5 billion years. It has felt the same sunlight that once warmed liquid oceans, and it has felt that sunlight grow colder as its atmosphere thinned and its warmth bled away into space. If Mars ever had life, that life is gone, lost to cosmic circumstance, to the slow death of a magnetic field, to the indifference of physics. But we are not indifferent. We are the one thing in this universe that has evolved the capacity to refuse indifference, to look at the void and push back against it with curiosity and will and ingenuity. That is what makes us remarkable, not in spite of how small we are, but precisely because of it. The fact that something as fragile and brief as a human life can contemplate the birth of the universe, can understand the death of stars, can build machines that journey to other worlds, that is not insignificant. That is perhaps the most significant thing in the observable cosmos. And it all starts with looking up, asking why, and refusing to pretend the question doesn't matter. So the next time you step outside on a clear night and feel that familiar pull, that strange, inexplicable ache when you look at the stars, don't push it away. Don't call it pointless or overwhelming. That feeling is ancient and it is correct. It is your intelligence recognizing the truth of your situation, that you are alive, briefly, on a small rock in a vast and mysterious universe that is far stranger and far more beautiful than any story we have yet told about it. The mysteries of Mars, the silence of the cosmos, the darkness of black holes, the invisibility of dark matter, the acceleration of space itself,
These are not obstacles to understanding. They are invitations. They are the universe extending a hand and asking whether you are willing to take it. Every great discovery in history began with someone who was willing to feel small, feel uncertain, feel the weight of the unknown, and then take a step forward anyway. That step is always available to you. That step is always worth taking. The universe began with a single moment of unimaginable creation. It will end on timescales so vast they exceed comprehension, in cold, dark silence as entropy takes its final toll on everything. In between those 2 points, for a window of time that is cosmically brief but humanly infinite, consciousness has existed. You are part of that window. Mars is part of that window. Every question we've explored tonight is part of that window, and how we use this time, what we discover, what we preserve, what we dare to reach for, will determine whether this brief, unlikely, extraordinary experiment called humanity was worth the trouble the universe went to in creating us. I think it is. I think you do too. The stars aren't going anywhere, neither are the questions, and neither, as long as we keep looking up, are we.